So, if you've ever spent any time on a Linux system, you know that permissions, well, they're everything. They're the digital bouncers at the door, deciding who gets in and what they can do. And look, mastering them isn't just some nice-to-have skill. It's absolutely crucial for security, for running a system properly, and yeah, for crushing that next technical interview. Okay, let's get right into it.
Ah, yes. Probably the two most frustrating words you'll ever see in a terminal. Permission denied. Come on, we've all been there. You're trying to run a script, you're trying to save a file, and the system just shuts you down. Well, today, we're going to pull back the curtain on that message for good. All right, so before we can start changing permissions, we've got to learn to speak their language. It really all comes down to answering two really simple questions. Who are you, and what are you actually allowed to do?
Every time you list files in the terminal, you see this string of characters. I know, at first glance, it just looks like a bunch of gibberish, right? But believe it or not, that single line of text is a complete security policy for that one file. It holds all the secrets.
Let's actually break this thing down. That very first character tells you what type of file it is, but after that, the next 9 characters are the real meat and potatoes, and they're split into 3 little groups. The first group is for the user, that's the file's owner. The second is for the group, which is, a collection of users. And the third is for others, which is pretty much everybody else. And inside each of those groups, R is for read, W is for write, and X is for execute. Simple as that.
So, now that we can read the policy, let's talk about how to rewrite it. And the number one tool for that job is the chmod command. It stands for change mode, and it's basically your master key for setting permissions. You've basically got 2 main ways to use chmod. Symbolic mode is pretty cool for making small, specific tweaks, like, hey, just add execute permission for the owner. But numeric mode, the one that uses numbers, is way more powerful and efficient for setting the entire permission set all at once. Honestly, it's what you're going to see most of the time out in the wild. Now, the really clever thing about this whole numeric system is how simple it is once you see the pattern. It's just addition. Read is worth 4, write is worth 2, and execute is worth 1. You just add them up. So if you want someone to be able to read and execute a file, that's 4 plus 1, which is 5. Want them to have full control, read, write, and execute? That's 4 plus 2 plus 1, which gets you a 7.
This simple math makes a super common permission set, 75.5, really easy to figure out. Let's do it together. That first number, the 7, that's for the owner. We just saw that 7 means read, write, and execute, full control. The next 2 numbers are both 5, and that's for the group and for everyone else. And since 5 is just 4 plus 1, that gives them both read and execute permissions, but, and this is key, not write permission. This is a classic setup you'll see all the time for websites and shared apps.
Okay, let's look at some real-world examples. If you run chmod 700 on a script, you're locking it down so that only you, the owner, can touch it. That's perfect for something sensitive. Chmod 755 on a web directory? That's just standard practice. And see that little R flag? That means recursive. It applies the permissions not just to the folder, but to every single thing inside it. But be warned, that is a very powerful tool, and if you're not careful, it can open up security holes.
Okay, so we've nailed down how to change what people can do. Now let's talk about changing who these rules even apply to in the first place. And for that, we have 2 other key commands, chown and chgrp. Chown, or change owner, is a massive deal for system administrators. I mean, think about it. A developer leaves the company. You need to hand off all their project files to someone new. Chown is how you do that. It's all about maintaining control and accountability. And using it is pretty straightforward. You can change just the user, like that first example, or, and this is a really handy shortcut, you can use a colon to change both the user and the group at the exact same time. Super efficient. And yep, just like chmod, it's got that recursive R flag for changing ownership of a whole directory and everything inside it.
Now, while you can change the group with chown, sometimes that's the only thing you want to do. And that's exactly what chgrp, or change group, is for. This is the perfect tool for managing team access. When a file needs to be worked on by the devs team instead of the marketing team, you just use chgrp.
So, we've gone through all the theory, but as we all know, things don't always go according to plan in the real world, right? So let's talk about the common errors you're guaranteed to run into and, more importantly, how to fix them. This is a huge part of the job.
Does this one look familiar? This is probably the #1 error you'll hit when you first start messing with ownership. But don't worry about it. It's not a bug. It's actually the system working exactly how it's supposed to, and for a really good reason.
So why does it happen? Well, it's simple. In Linux, you can't just give your files away to someone else. Only the person who currently owns the file, or the system's superuser, root, has the power to change ownership. It's a security feature to stop people from just dumping files on other users. So what's the fix? Your best friend in the terminal, the sudo command. It lets you borrow those root privileges for a moment to get the job done.
And here are a couple of other common traps to watch out for. Using that recursive flag on the wrong directory can accidentally blow a huge security hole in your system, so always double-check your path. Also, if you try to give a file to a group that doesn't even exist, the system's going to tell you no. You can easily check if a group is real with a command like getEntGroup.
Okay, let's change hats for a second and put this all in a job-focused context. Because when you sit down for a technical interview for any kind of Linux job, I promise you, these commands are going to come up. But they're not just looking to see if you've memorized them.
What they really want to know is if you get the why behind the commands. Are you thinking like a system administrator? Can you troubleshoot a problem on the fly? And maybe, most importantly, do you actually understand the security side of what you're doing?
When you boil it all down, they are testing your judgment. They want to see that you can flip between symbolic and numeric modes without a problem, that you respect the damage a recursive flag can do, and that you understand the principle of least privilege, which just means only giving people the absolute minimum access they need to do their job, and nothing more.
And that brings us to the final boss of interview questions. You will almost certainly be asked about this number, 777. It's the open sesame of the permissions world.
See, chmod 777 gives read, write, and execute permissions to literally everyone, the user, the group, and anybody else on the system. And yeah, it might seem like a quick and dirty fix when you're getting a permission denied error, but a senior admin knows this is almost always the wrong answer. It's a huge security risk. The real test of your knowledge isn't knowing the command, it's being able to explain why you shouldn't use it and what the safer, better alternative is.
Look, understanding chmod, chown, and chgrp is about so much more than just typing commands. It's about understanding the very foundation of security on a Linux system. You've officially been given the keys to the kingdom. So the real question is, how are you going to use them to build systems that are not just working, but are truly robust and secure?